This is section 7-2, chapter 7. This is recording number 2. In the last video, we talked about how the T curves, that's the blue guys here, they start to look more and more like the Z curve. They start to look more like the standard normal distribution as the degrees of freedom gets larger and larger. So here DF stands for degree of freedom. So T, degree of freedom of 5, doesn't really look that much like the standard normal. But if you have a T distribution, degree of freedom of 20, as you can see, it does look quite a bit like the standard normal distribution. So what's the degree of freedom? Degree of freedom numerically to calculate it is just n subtract 1. So it's 1 less than the sample size. So if you have a degree of freedom of 20, that means your sample size was 21. A more intuitive approach, however, would be to talk about it in terms of this. Now, this explanation here is not that hot. So let me try another explanation that might make more sense to you. So let's just do a little thought experiment and see if we can come up with a better way of looking at this. Let's suppose I'm in the classroom and I have 20 kids in my classroom, and I'm gonna pick some kids to go out there and play a tug of war, okay, or keep away or something like that. Some game where there's no positions. You just go out there and play. All right. So if I have 20 kids in there, the first kid I choose, how many kids can I choose from? I can choose from 20 because I started with 20. The next kid, so I pick the first kid and I say, okay, go out there and play. I pick the next kid. How many kids do I have left? I have 19 kids left. So I have 19 positions or 19 kids that I can choose from. So I send that kid out. So I pick another kid. How many do I have left to pick from? I have 18, and so forth. Well, when I get to the end, let's say I get to the last 3 boys or 3 kids, I have 3 kids I can pick from, then I have 2 kids I can pick from, and it's a random chance, right? Everybody has the same opportunity to be picked. But when I get to that last child, it's not random anymore because that's the last kid. He's the last one that I can pick from, okay? Because I told you there was 20 kids in the classroom and there's 20 kids I want to pick for this tug of war. So that's the concept. The degree of freedom is 1 less than whatever it is that you're picking from. If you have a degree of freedom of 20, that means that you had 21 people that you are going to pick from. If you have a degree of freedom of 19, that means you had 20 people that you were going to pick from. Now his example here, I want to explain it to you because it's not very clear, just to help you learn how to read a math book. He says if the mean of 5 values is 10, then 4 of the 5 values are free to vary. Now think about that. Does that make sense? If you have 5 values, okay, and you add them up and divide by 5 and you get 10, well, the first 4, you can pick anything you want. You can pick any numbers that you want. That last guy is not free to be chosen any value because the first 4 dictate what the last guy is going to be. So once you pick 4 values, the 5th value must be a specific number in order to get them to add up to be 50. The 5 values have to be adding up to get you 50 because in order to get a mean of 10, you must have a total sum of 50. And the reason that's true is because 50 divided by 5 is equal to 10. That's what we mean by the mean. It's the sum divided by the number of guys in your sample. So 50 divided by 5 is 10. So the first 4 you pick up The first four that you choose will dictate what the last guy is that you choose. So what we say is that the degrees of freedom is 5 take away 1 equals 5. It's one less than the total number that you're picking from. Okay, so the only warning here is that you have to be cautious because we use the term degree of freedom. That has a specific meaning. For this particular test, for the t-test, degree of freedom is exactly n minus 1. Some other tests used later on, the degree of freedom will not be equal to n minus 1. There's a different formula for it. It's a different way of calculating it, although the concept is still the same. Okay, so the formula for finding the confidence interval using the t-distribution, it has this so-called critical value of t sub alpha over 2. Now that's exactly analogous. It's very similar to what we had before. Previously we had z alpha over 2. There's a table in the back of the book that has these values, so that part's the same. Okay, so how are we going to use this table? Let's see if we can take a look at the table and figure this out. Okay, so you go to the back of the book. Here's sort of a table of contents here of what all the tables are. And the first table, table A, factorials, that's actually on the same page as the table of contents is. So as you can see, B is the binomial distribution, C is the Poisson distribution, and so forth. So we want the t distribution. That's table F. So we scroll down, or in your book you flip the pages. So let me do that offline. Okay, so here's table F, and it's the so-called t distribution. Down this column here, that's the degrees of freedom. Now compare that to the z table. The z table across the bottom on the left-hand side, we had something different. So if you look back on your z table, I think it's table E if I'm not mistaken, on the left-hand side there, that column was the z scores. Okay, so you got to be very cautious on these tables. Make sure you look at them ahead of time. In any event, the t distribution, down here we have the degrees of freedom that we're interested in. So in a sense, it's very, very similar as the sample size. So on the left hand side, as the sample size gets bigger and bigger, you go down these rows. Now I know it's not sample size, it's the degree of freedom, so that's one less than the sample size. Okay, so then we have the so-called confidence intervals. How confident do we want to be? Okay, so that information is up here. So I'm going to go back to the text now, and we'll bounce back and forth to try to compare and contrast the table with what the textbook is saying. One second. Okay, so as you're reading the book here, I hope that you're also looking at the back, looking at the table of what I just showed you, and it will tell us, how to do this right now. Okay, so give me a second here. So I don't want to treat you like little kids, but let me just read this to you because it's very complex the first time you see it. Okay, the top row of table F, which is labeled confidence intervals. So let's look at that. Okay, confidence intervals. You see that? Okay, that's what we're going to use right now. These other two rows, the one-tail and the two-tail tests, we're not going to use those yet. We're going to use those in a later chapter. So for our purposes in chapter 7, we're going to use just the top row. So if I want a 90%, this is what I'm looking at. If I want 95%, this is what I'm looking at. So that's what he says here. Let's see. The other two rows, one tail and two tails, will be explained in chapter 8. We're not going to use those yet. Okay, so example 7.5 shows us how to find the values in table F for a certain enumerated t sub alpha over 2. So when we're dealing with confidence intervals, we're always going to be dealing with these t sub alpha over 2 because it's a confidence interval where our errors will be on the left hand side and the right hand side. Okay, so the t alpha sub 2 value for a 95% confidence interval. Okay, the sample size is 22, so let me go bounce back to that. So it's 21 and we want 95%. Okay, so if the whatchamacallit, if the sample size is 22, that means that the degree of freedom is 21. We put our finger here, we go across here, and we want 95%. It's 2.080. There it is, 2.080. Okay, so that's the critical value. That's the appropriately chosen t value that we're gonna use in our formula here. Okay. He talks here about how sometimes it can be kind of a big number, right? The degree of freedom, if it's a large sample size, so like if the sample size is 69, the degree of freedom is if the sample size is 69, the degree of freedom is 68. Okay. Well, if you look at the table, 68, that's somewhere between 65 and 70 on my table. Let's go to that table. 60. See it? You get up here, instead of going separated by 1, they get separated by 5, and I think later on they get separated by even more. So 65 is between, or 68, I mean, is between 65 and 70. So what do you do? There's got to be a rule for that. So what do you do here? He says there's two approaches. Some texts say use the closest value. And this text, and our text, what we're going to do is we're going to round down to the nearest table value. So 68 rounds down to 65. Okay, so I'll let you read all that, but it's pretty simple. It's just a table. Okay, so now, what the heck is the formula? How are we going to actually use that? Well, we're going to get into that in the next formula in our little blue box here, okay? Now, remember what I told you. These are all in the book on a single page. At the end of the text, or the end of the chapter, they have all of these formulas. Each chapter, they have the formulas on one page. And a lot of times it's a lot easier to understand these if you look at them at the same time. It's very difficult for me to bounce back and forth in the text, however. It's very difficult for me to bounce back and forth using the electronic text. It's just too hard. As you can see, it's just too hard to find things. But I urge you, look at that textbook. Okay, and if you don't mind, I'll show you one more time. This is at the end of chapter 7. Here's the summary page, which I told you, doggone it, read it. And then here's the important formulas here. Okay, here's the important formulas. Here's the one for section 7.1. Using the Z, the margin of error here, using the Z score. Here is for section 7.2, we're using the T distribution instead of the Z distribution. But as you can see, looking at these two, they're very, very similar. Okay, let me bounce out of here again. Okay, so here's the formula. Okay, if I give you a sample of size n, and I give you the data values, I can very easily calculate the x bar. I can very easily calculate the s for the sample. I just do the calculation. There's a formula for it. There's a bunch of computer programs that will do it for you. So it's not hard at all. You calculate the x bar, you calculate the s. Okay, and here's the assumptions. But we're going to, as I say, the assumptions will be stated in the exercises. Okay. All right. So there's the formula that we're going to use. I'm not going to read it to you. I think that's not a good use of your time, but just carefully look at that. Make sure you understand what every term is. You know what the X bar is. This is the guy we get off of the table. S is what we calculate. That's the standard deviation of the sample. N, of course, is the sample size. Okay, so next we're going to do example 7.6. It always makes a lot more sense when you have an example to work with.